Hi, good evening to everyone. As you screen on the screen, our topic is today a comprehensive literature evaluation on the coverage and connectivity considered in the wireless sensor network using configurable coverage protocol as a baseline. And we're going to see about some of the few topics as it is. And after that, we are going to what I have done in literature review and what is the future goal I have to do. We will see it on introduction. Wireless sensor network means a network of battery dispatched and dedicated sensor that monitor and record the physical condition of the environment and forward all the collected data to the central location. It is also used to measure the environmental condition like temperature, sound, pollution level, humidity, and wind. Coverage represents how well the sensing goals of the network is accomplished, and connectivity represents how well the information can be delivered among the sensor nodes or to the central controller. Managing network coverage and connectivity is the important in sensor networks. The coverage and connectivity management functions are classified into microscale management and the macroscale management according to the geographical scale within which the sensor nodes is collaborated. Now we are going to say about what is the wireless sensor network and what it does. Wireless sensor network is an infrastructure-less wireless network that is deployed in a large number of wireless sensors in a ADHOC manner that is used to monitor the system physically and environmental conditions. The sensor node are used in wireless sensor network in the onboard process that manages and monitors the environmental in a particular area. They are connected to the base station which acts as a processing unit in wireless sensor network system. This is about the wireless sensor networks. Now we are going to see about what are the components of wireless sensor network. One thing is sensor, radio nodes, evaluation software, WLAN access point. We are going to see a sensor in a brief content. Sensor in wireless sensor are used to capture the environmental variables and which is used to offer data cognitions, sense the signals and convert it into the electric signals. Radio nodes. It is used to receive the data procedure by the sensors and sends it to the WLAN access point. It consists of microcontroller sent by a radio nodes wirelessly, generally through the internet services. Evaluation software. The data received by the WLA transistor, external memory, and the power resources. WAN LAN access point. It receives the data which is an N access point of endpoints is processed by software called as evaluation software for presenting the report of the user for further processing of the data which can be used for processing, analysis, storage, and miming of the data. These are the four things as the components of the wireless sensor networks. Applications of wireless sensor networks. The wireless sensor networks is majorly used in few things. Let's going to see about that. IoT, Internet based of things, surveillances and monitoring of the security and threat detection, environmental temperature, humidity and the air pressure, noise level of the surrounding, medical application like patient monitoring system, agriculture, landslide detection. And next, we are going to see about challenges of a wireless sensor network. Majorly, the performance of the wireless sensor network, which based upon the connectivity of wired or wireless networks. And the some of the challenges are quality of the service, security issues, energy efficiency, network through output, performance, ability to cope with the node failure, cross-layer optimization, scalability to large scale of development. As per what you said before, the wired was wireless sensor networks. We are going to see now. Sensor networks can be wired or wireless. Wired sensor networks used Ethernet cables to connect sensors. Wireless sensor networks use technology such as Bluetooth, cellular, Wi-Fi, or near field communication (NFC) to connect sensor. Wireless sensor networks are easy to deploy and maintain and offer better flexibility of the device. With the rapid development of the sensor and wireless technologies, wireless sensor network have become a key technology of an IoT. It is the major internet of the technology. Wireless sensor networks does not need the physical network infrastructure to be modified. And then I have taken some points in the five of those PPT. And the sum of the survey of the literature review is the coverage and connectivity of the management and function are characterized in the monitoring and controlling of the network coverage and connectivity in both microscale and the macroscale level. The integration of these components into a unified coverage and connectivity management framework was then proposed in the Coverage and Connectivity Management System. The Configurable Coverage Protocol (CCP) proposed in a coverage preserving nodes scheduling serve the purpose of a microscale coverage and connectivity control. Meanwhile, the vacancies estimate the scheme of proposed in CCP Configurable Coverage Protocol also provide a way of compute the microscale vacancy of the given network and thus also serves the management functions of microscale coverage monitoring. All these proposed solutions are to the coverage and connectivity management components described in a coverage preserving nodes, scheduling, microscale connectivity monitoring, and macroscale topology, hold reduction, and monitoring are distributed algorithm. They are efficient, excuse me, they are efficient in communication and energy cost and scale level to the very large and dense wireless sensor. A unified coverage and connectivity management framework was proposed in a coverage and connectivity management system. The framework maps all these described individual components into their management functions and service. The dependency among these functions and service were carefully investigated. The future work I am to do in this CCP protocol in the wireless sensor network are proposed in a coverage preserving no scheduling control on the microscale coverage and connectivity. They are apparently many of the formulations of the problems, coverage and connectivity control. The most obvious extension is to extend the CCP protocol to support K coverage and K connectivity. The CCP protocol only focus on the microscale coverage and connectivity and control. An extension to this work is use the proposed vacancies of estimation method for macroscale coverage monitoring. Macroscale coverage monitoring is an important management service that is not included in the management framework proposed in this thesis. The macroscale hole monitoring is investigated in the macroscale topology hole detection and monitoring. The problem of migrating macroscale holes such as a node development scheme to avoid the formation of the large hole, as well as the tree development schemes to eliminate the extension of a hole are not studied in this thesis. These components can be investigated as a future work to make a proposed management and the framework more complete. The research work in this thesis heavily relies on the connectivity based localization, which in turn relies on the acceptance of the Poisson random placement of sensor nodes. This assumption does not cause the trouble for the protocol proposed for the microscale coverage and connectivity and monitoring. However, this is an important assumption of the macroscale connectivity and coverage and monitoring, especially of the whole monitoring and estimation. The impact of the other distribution of the node placement to the macroscale connectivity and coverage monitoring can be investigated as a future work. At last, although the individual management functions and the services has been extensively stimulated, and some of them have been implemented, and these tests are the real sensor network testbeds. The stimulation of the testbeds implemented of the proposed framework has not been evaluated and can be considered as a future work. And then we are coming into the last point of the conclusion. The modern research on the wireless sensor network state was started around the 1980, driven by the military application. However, the technology of a small sensor was not quite ready at that time. during the last decade due to the rapid development of the various enabling technologies for the sensor. Research on the sensor networks has regained significant attention. Beside the original military applications, wireless sensor networks are used in many industrial and civilization applications, including industrial process monitoring and control, environment and habitat monitoring, healthcare applications, home automation, traffic control, and etc. It playing a major role on these networks. An idea of a wireless sensor, it is the fact of so existing that the small sensor are expected to be everywhere in the future of the world. Wireless sensor network are also configuration oriented, different application requirements, different types of sensor nodes, and different system models and assumption may result in a completely different problem formulation and the protocol designs also. Several protocols on monitoring and controlling the network coverage and connectivity, both in microscale and the macroscale levels, were proposed. The detailed research results and contributions of this thesis are summarized in our next sections. Thank you so much.